The James Webb Space Telescope, JWST, is like the best at seeing stuff in space. It's looking at our solar system, planets around other stars, and everything else in the universe to figure out where we fit in. Recently, some scientists aimed the JWST at a star 120 light-years away. Guess what? It looks like there might be carbon stuff in the air of a planet that could have oceans. That's a kind of crazy, right? It's a planet way different from anything we have around here, and it makes you wonder if other planets out there could have life. Want to know more about this planet they found? Keep watching! And if you like space stuff, hit subscribe, like this video, share it, ring the bell so you don't miss anything. So, NASA's JWST looked at exoplanet K2-18b. It's big, almost 9 times bigger than Earth. This planet is special because they found carbon stuff like methane and carbon dioxide in its air. Some older research said K2-18b might be okay for life. It probably has a lot of hydrogen in its air and oceans all over. Before, the Hubble Space Telescope took a first look at the air of this planet, which is in a spot where it could have life. This helped us learn more. K2-18b is pretty far, like in the Leo constellation, 120 light-years away. It goes around a dwarf star called K2-18, which isn't too hot. Planets like K2-18b, sort of between Earth and Neptune size, aren't common around here. Because we don't have any like it, it's interesting to think that K2-18b might have lots of carbon and air mostly made of hydrogen. People who study space think planets like this might be good spots to find life. The fact that there's methane and carbon dioxide, but not ammonia, makes scientists think this planet might have an ocean under all that hydrogen air. Some early research even thought they might have spotted dimethyl sulfide, something that life on Earth lets off, in K2-18b's atmosphere. Plankton in the oceans makes most of it on Earth. We still need more proof for this, though. The JWST should be able to tell us if there's enough dimethyl sulfide there. Someone from Cambridge said that just because K2-18b is in the habitable zone and has carbon stuff, doesn't mean there's life. It's big. It could have a thick, icy layer around its core. And even if it has oceans of water, they might not be good for life. Still, scientists were able to get the best look ever at the air of a smaller planet that could have life. They figured out what molecules are there. They did this by watching light from K2-18b star as it shined through the planet's air. K2-18b is what's called a transiting exoplanet. It dims the light when it moves in front of its star. That is how NASA's K2 mission figured out this planet was there. During these transits, some sunlight goes through the planet's air before space telescopes like JWST catch it. As sunlight goes through, it leaves clues that help scientists figure out what gases are in the air. The scientists plan to use the JWST to check their work and find out more about the weather on K2-18b. Their main goal is to find signs of life on planets that could support it. That would be a super big deal for us. Plus, the JWST has made some other crazy good catches. Scientists saw some big, sooty molecules in a faraway galaxy. It's the earliest they've ever seen stuff like that in the universe. I think it's both awesome and a little scary because these far-out finds are changing how we understand the universe. The cool thing is these molecules were in a galaxy that formed way back when the universe was only a kid. These carbon molecules are like what we find in oil and smog here, and they're huge and complex. It's wild because they formed so fast after the Big Bang. We thought it took longer for that to happen if you look at what we know already. The light we saw from this old galaxy started its trip less than 500 million years after the Big Bang. The universe is like nearly 14 billion years old now. Talk about seeing back in time. The Webb telescope let us spot these molecules, and it will let us keep making catches like this for a long time. Could we find even more of these molecules if we look back even further, maybe closer to the Big Bang? That gets you thinking about what we know, or think we know, about how it all works. Before, we could tell these kinds of molecules were in old galaxies, but the Webb telescope lets us see where they are exactly. It's also weird that these molecules aren't spread out evenly in that old galaxy. What's also wild is that this galaxy was already as big as ours, with stars making just as much of the carbon and oxygen as the ones in the Milky Way. And this galaxy was only a tenth of the age. The deeper we go, the more we realize the cosmos is huge and complex. Every new thing we find gets us closer to figuring out what's hidden out there. Tell us what you think in the comments. If you like the vid, subscribe and turn on notifications. The James Webb Space Telescope keeps teaching us new stuff. It is changing how we see exoplanets and other things, pushing what we know about everything. This telescope lets us go deeper into space than ever, finding mysteries that have always been a secret to scientists. The discovery of some complex organic molecules in faraway galaxies is just one thing pointing to changes happening in our knowledge. One cool thing about all this is maybe life, or at least the stuff to build life, is out there in places we thought couldn't support it. Spotting carbon stuff in the air of planets like K2-18b opens the door to studying planets that might be like Earth. Some of these compounds, like methane and carbon dioxide, are linked to life here. But just because they're out there doesn't mean there's life. We have to look closer at what it takes for life to exist somewhere else. The Webb telescope is great at looking at the air on other planets. It lets scientists spot basic elements and those more complex molecules that might hint at life. This all helps us understand these planets better. Finding new planets, studying their air, and finding signs of life is more possible than ever. Every time we look, we're reminded how much is still out there. Besides looking at exoplanets, the JWST is teaching us about how galaxies form. By seeing old galaxies, astronomers can follow the history of how stars formed, where the elements are, and how galaxies grow. This helps us understand how our galaxy started and how it has changed. Finding aromatic hydrocarbons way back is amazing. It tells us that the building blocks of life might have existed longer ago than we thought, which raises questions about the start of life. As we keep checking things out, every new thing we find brings us nearer to figuring out the really big questions. Are we by ourselves? What does life need to grow? How did the universe change? What's next? The James Webb Space Telescope is giving us the tools to deal with these questions, giving us a peek into the far reaches of time and space. We can expect even crazier finds from the JWST. It will keep changing what we know already. The chance of seeing new planets, studying their air, and finding life is bigger than ever. With every look, we know there's more to learn. The Webb telescope leads the way. It is not only a tool for astronomers, but a symbol of how we want to learn more about the universe. As we look forward, we can be sure that discoveries made by the JWST will keep changing how we understand the cosmos. Planets like K2-18b that are bigger than Earth but smaller than Neptune are kinda rare. We don't have any like that around here, so the idea that K2-18b has a bunch of carbon and a hydrogen atmosphere is really interesting to scientists. A lot of them think these planets could be perfect for finding life. The fact that there's methane and carbon dioxide, but not ammonia, makes it seem even more like there might be an ocean under all that hydrogen. Some early studies figure that dimethyl sulfide, which is made by living stuff on Earth, might be there too. Mostly ocean plankton makes this on Earth. But we aren't really sure of the dimethyl sulfide K2-18b. More peaks, using the JWST telescope should help us know for sure if there's dimethyl sulfide in K2-18b's air. One scientist from Cambridge said that even though K2-18b is in the habitable zone and has carbon stuff, that doesn't mean life is there for sure. It's big, 2.6 times Earth, so it might have a lot of icy stuff under the surface, kinda like Neptune. Also, it got a thin hydrogen air cover and a surface ocean. Although liquid water oceans are predicted on this exoplanet, there's a chance that these oceans may not support life. Still, researchers got the most detailed look ever at the air of a possibly livable sub-Neptune planet. One of the Cardiff University teams said they figured it out by checking out light from K2-18b star as it went through the planet's air. K2-18b is what they call a transiting exoplanet, meaning it gets dimmer when it goes in front of its star. That's how NASA's K2 spotted it at first. When this happens, some sunlight filters through the exoplanet's atmosphere before reaching space scopes like JWST. Sunlight leaves clues as it goes through a planet air, and we can read the clues to know what gases are there. The team wants to use the JWST to get more info and check out K2-18b's weather. The team ultimately wants to find signs of life on habitable exoplanets, a game-changer. Also, the JWST found these nasty molecules way far out in a galaxy. That's the earliest we've seen those molecules in the universe. I think this is scary because these new findings in space are transforming our thoughts on cosmology. It is important because these molecules were found in a galaxy that was made when the universe was 10% of its current age. These things are in petroleum and smog. What's remarkable is they were made so quickly after the Big Bang. The light detected from this galaxy just started less than 0.5 billion years after the Big Bang. The universe is 13.8 billion years old. This means we are witnessing the universe's first steps. Impressively, we have the Webb telescope to thank for capturing the molecules. If we check even further, we may see more by the Big Bang. This causes confusing for science. Despite previous attempts to detect organic molecules in ancient galaxies, confirmation had been elusive until Webb resolution came along. Furthermore, the uneven distribution of these molecules in the early galaxy SP4 to 1847 remains an unsolved mystery. This galaxy was massive compared to the Milky Way. As we grow more curious, we are humbled. Furthermore, we are closer to unraveling mysteries. Don't forget to like. As we advance in our understanding of the universe, the James Webb Space Telescope keeps giving us new opinions. This telescope pushes our beliefs. This great telescope allows us to uncover mysteries scientists have wondered about. The organic molecules are transforming the universe. The fascinating thing is life can stay somewhere you thought it couldn't. The carbons in the air let us think life can live like Earth. The methane hints at life. The telescope finds where our life signs are. Its knows our elements. Then, it can tell us the possible habitability. As knowledge grows, we find signs of life. This also points to biological activity. In addition to planets, the JWST shows how galaxies were made. The astronomy is able to look back at galaxy with star formations. It is crucial for our galaxy's origins. Finding the hydrocarbons shows what we know. We must ask ourselves deep questions as we keep going. Like, are we alone? What do we need to grow life? In the coming years, we can expect more to come. There is lots more to learn about the universe. It's not just a tool. It is humanity's curiosity. So it transforms into something incredible. It answers the humans who has been wondering. As the telescope keeps finding the mysteries of the cosmos, it is clear that it has changed the meaning of being in space. It is able to see clearly, opening new ways into research. The galaxy and stars formations have the potential to change how we believe the universe has began. We can see the galaxy through a few hundred years and see the story by the Big Bang.